Alrighty, so today, before we get onto our lesson or assignment, let's go over our kickoff. You were to work on this exam review stuff, and remember, you hold on to this until the end of the quarter. 2 or 3 days a week, we'll be working on a couple of questions for your exam review at the end of the quarter. And then at the end, we're going to submit pictures of all of your work from the entire quarter into one big submission pile. So please hold on to it. Don't lose it. Take pictures as you're doing it. So just in case you lose the paper, you still have the picture. But really quickly, let's check your answers. You were just doing numbers 8, 9, and 10 today. So here are your answers for numbers 8, 9, and 10 down at the very, very bottom. The first 7 questions, 1 through 7, that was from, I think it was Tuesday. It was earlier this week. We answered the first couple of questions on the top half of the page. So check your answers really quickly. I don't think it should take too long because it's just 3 questions, and I'll kind of briefly go over them for you. But I'll give you a couple more seconds to check them. And if you get the wrong answer, that's okay. Just fix it. You learn from your mistakes. I don't recommend you erase it. Keep your mistakes there so you can see what you did wrong, so then you can learn from it. You want to make sure you don't make that same mistake again. Okay. All right, so let's go back and look at the questions again really quickly. For number 8, it says a farmer wants to use 500 feet of fence to create a pasture for his horse. The area created by this is modeled by the function A parentheses W equals 250W minus W squared, where W represents the width in feet. What is A of 50? Okay. So I gave you guys little hints there. This is pretty much saying like A or W equals 50. All you have to do is take that 50, plug it into W, and then solve with PEMDAS, okay? And then once you do that, you get A of 50 equals 10,000. Okay, so you just plug in that 50 into anywhere you see the W, solve with PEMDAS, get your final answer, and then that's it for number 8. Number 9, it says, which of the following are not a function? Circle all that apply. So in order for it to be a function, that means the x's do not repeat. So if yes, it is a function, the x values do not repeat. So for this, number 9, all you're doing is looking at all of your x values. You don't even look at the other column. So you're only looking at these ones here. So from A, the first table, you can see your x values. We have a -2, 3, -5, 7. None of those are repeating. So yes, that is a function. But if you look at B, we've got the -3 and the -3. Those are repeating, and 5 and 5 are repeating. So it is not a function. So the second table, or B, is not a function. Okay, and then C, the third table, -1, 2, -3, 10. None of those are repeating. So yes, that is a function. And the last one, D, these are all -2. So they're all repeating. So D is not a function. And I know some people kind of stress about the Y value or the other section of the table. You don't need to look at that at all. When you're determining if it's a function or not a function, all you do is look at your X values. If the X values are up there only one time, then yes, it is a function. If it's up there more than once, then it is not a function. Okay, and the last one, number 10. Oops, so D is an answer there too. The second and fourth one are your not a function for number 9. But number 10, it says, based on the data gathered by the U.S. Census Bureau, the population of the United States is shown on the graph to the right from 1900 to 2010. The equation that best models the data is P of T equals all of that there. What is the domain of the graph of P of T as shown? So they're really just asking, I underline your main question, because pretty much all the rest is just kind of to confuse you there. It's really asking, what is the domain of the graph here that's on the right? So they're just asking for the domain. Domain, I gave you a little hint. That's all of your X values. That means range is all of your Y values. But we're only focusing on domain. So you're looking at all of your X values from left all the way to right. So all of your X values here, we start at 0 and then we end in between the 100 and the 120. So that is half of that, it would be 110. So that is why B is the correct answer, because T falls in between 0 and 110. Okay, if you chose D, that's just listing out all of these points, their X values, but it's over the time of years. So we wanted to know there's a line in between. So you got to make sure you include all of those points that are there. So that's why it is B for number 10. Any questions on any of that review stuff? Or if you're good, let me know you're good. Type you're ready to go or you're good in the chat. And then we can actually go on to the assignment. So let me know in the chat if you have questions or if you're all good. And then just another reminder, hold on to all of your exam review stuff until the end of the quarter. We will submit it at the end of the quarter all together as one. Okay, this is just all of your exam review. Alrighty, so I see lots of people saying they're good, good, good. Perfect. So the assignment for today, it's on simplifying radicals, what we worked on with our notes yesterday. But before we do that, let's talk about our week 3 code word. So hopefully you guys think this is funny. I don't know. We'll see. So we'll do this first. We'll do the code word first. We'll say it is April Fool's. Because today is April Fool's Day. I'm not sure if you guys know that. Today is April 1st, April Fool's Day. So I just want to tell you guys a little funny joke. Last year, I think it was last year, maybe the year before, what I did for my students is I told them that I would get them all brownies. So they were all like really excited. And then I put on the screen a bunch of E's that were just brown. So that was the brownies. So I just thought it was really funny. They didn't really like it, but I thought it was funny. But your code word for week 3 is just April Fool's. So all of you guys that are here, you type something in the chat, you get your credit for the week. But if you're watching the video later, send me that message, April Fool's, so you can get your credit. Okay, so our assignment, you guys probably don't think that's funny, I'm sorry, but I do. So our assignment is on simplifying radicals. You're only going to be doing the odd numbers on both pages, page 1 and page 2. Okay, so there's a total of 2 pages here. There's 2 pages there. You're doing all of the odd numbers. That's pretty much only the left side of the paper. 1, 3, 5, 7, 9, all the way down on the left side of the paper. Before we do that, let's go out and list out all of our perfect squares. I kind of got it started here. Whoops. With our 1 squared equals, 2 squared equals, 3 squared equals. Go ahead and type in the chat. Tell me what any of the perfect squares are. Say like 4 squared equals, and then tell me what it is. I'll even do that one. So like if I were one of you guys, I would type into the chat, 4 squared equals 16. Go ahead and type into the chat any one of those, or you can do a couple of them. Let's go ahead and get these all filled out really quickly, all of your perfect squares, because this is going to help you guys out with this assignment. So go ahead and type into the chat any one of those. I see 3 squared is 9. Perfect. Go ahead and keep on going there. Type in all of them. Do one at a time. You can type in multiples. But I want all of you guys to tell me all of the perfect squares. 8 squared is 64. Perfect. 5 squared is 25. Perfect. 9 squared is 81. Awesome. Keep on going. 1 to the power of 2. Be careful with that. Make sure we do the number. It's times itself. So 1 times 1 is just 1. Same thing for all of these. Anything squared is that number times itself. So 7 squared, 7 times 7 is 49. 10 squared is 100. So 10 times 10 is 100. 6 squared is 36. So 6 times 6 is 36. Looking for 2 squared, 11 squared, 12 squared. 2 squared is 4. Yep, 2 times 2 is 4. Oh, someone got it before you. You almost had it there. 12 squared is 144. Last one, 11 squared. I personally don't like the 11, so I feel your pain, but someone's got to answer it for me. 11 times 11 There you go, 121. Perfect. 121. Awesome. Thank you, guys. So we've got all of our perfect squares. That's just the first 12 perfect squares, all of the numbers in blue. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. Those are all your perfect squares that are going to help us with this assignment here. So I would have you guys kind of pick and choose your questions normally on the assignment that we go over together, but I'm just going to pick those questions for you because I want to make sure we cover different types of questions. But the first one from this assignment here, I'm going to do number 1, our directions. It literally says simplify, okay? So this is going to be just like our notes from yesterday. We're going to be using our perfect squares. So 75, if you look at all of our perfect squares, it is not a perfect square. So we're going to have to actually break this one up. I'm going to zoom in here. We're going to have to actually break this one up. So a square root of something times a square root of something else. Okay, let's think and see, what can we multiply? What times what, where this first one here is a perfect square. Okay, so look at all of my perfect squares here. You're going to have to think about it. What can we multiply? What times what is 75? Well, let's think here. Let's do, whoops, there goes my pen. 25 times 3. If we were to do 25 times 3, or if you had 3 quarters, because they're 25 cents each, you would have 75 cents. So 25 times 3 is 75. But if you notice, 25 is one of our perfect squares, okay? That is going to help us with solving this problem here, okay? So first, I split it up, square root of 25 times square root of 3. And then from there, let's just simplify. What is the square root of 25? You can go ahead and type into the chat. Let's simplify this here. What is the square root of 25? 5. Perfect. So I'm going to simplify the square root of 25 is really just 5. And then I'm going to drag down this times square root of 3. So that is my final answer for number 1. This is what I want you guys to do when you're showing your work for this assignment today. I need to see this right here. If you only go straight to the answer, to me, it looks like you're cheating or you Googled the answers or someone just gave you the answers. Please don't do that. I need to see your work. And then also, if you make a mistake, it helps it better so we can kind of go over it and see where you made your mistakes. So make sure you show your work, but that final answer for number 1 would be 5 times the square root of 3. Okay? Pretty much all of these here are gonna need to be split up like that, except for number 3. Number 3, you can just go straight to your answer there. You don't need to split it up. But I'm not gonna do number 3. Next one we'll do together is number 5. Yep, number 5. Okay, so 80, if you look at our list here, 80 is not a perfect square, okay? Not one of those numbers written in blue. So we're going to have to split this one up. Square root of something times square root of something. Okay, the first one here needs to be a perfect square. I'm going to zoom out so we can see all of our perfect squares here. Okay, so you might not know this one top of your head, but we need to think of 2 numbers where one of them is a perfect square, just the first one. So I see a question in the chat about, do both numbers have to be perfect square? No, they both are not going to be a perfect square. For all of these answers here, the first one, number 1, that one's going to be a perfect square, but the second one is not a perfect square. Okay, so we want to think of the biggest perfect square. So can we do 144 times something is 80? No. It's got to be a number less than 80. So let's start with 64. Could we do 64 times something is 80? No, and then you would keep on going. Could we do 49 times something is 80? Keep on going until you get a perfect square times something else is 80. So think about it. Think about it. Kind of like what I did with number 1. The first one's a perfect square. The second one is not a perfect square. Here, if this helps, I will put in the second choice here of 5. So what times 5 is 80? And that first thing, the first one is going to be a perfect square. So it's going to be one of these numbers here in blue. I see someone said 16. Perfect. Let's plug that in, 16. Okay, I don't expect you guys to know 16 times 5 off the top of your head. So you could go and show your work over here on the side, multiply until you get that, 80. Okay. And then let's keep going from there. Let's simplify our square root of 16. What is the square root of 16? And you can type that in the chat for me. Square root of 16 is 4. Perfect. So here's my 4. And then I'm just going to drag down that square root of 5. This is my final answer here for number 5, the 4 times square root of 5 that I put a box around. That is my final answer. All of this here, I just showed my work. Okay, let's do another one. Let's pick a smaller number. So hopefully it's a little bit easier here. Number 7. Okay, we got the square root of 8. Okay, if you look and see at all of our perfect squares, is 8 a perfect square? Yes or no? Is 8 a perfect square? Look at all of our information here that we wrote down at the very, very beginning. It is not a perfect square, so that means we're going to have to split it up. Okay, square root of something times square root of something. The first one is a perfect square. The second one is not a perfect square. So what can we multiply? What times what is 8? Or the first one is a perfect square. That means the first one, you're going to use one of these numbers here. I see 2 and a 4, 4 and a 2. Perfect. Let's go ahead and write that out. 4 is your perfect square, so I'm going to put that one first, and then the 2. 2 times 4, 4 times 2, it's the same thing. They're both 8. But remember, we're going to get into this pattern, putting your perfect square first. That's why I put the 4 first. And then we're going to simplify. Now, let's do what is the square root of 4? You can go ahead and type in the chat, what's the square root of 4? 2, perfect, because 2 times 2 is 4, and then I'm just going to drag down this times square root of 2. And then that's your final answer for number 7. Okay, so that is what you're going to be doing on the first page. You're just working with only numbers on the first page. You're only going to be doing the left side, 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. Will you guys be okay to finish this first page on your own or with a partner? If you guys talk to anyone in here, are you guys gonna be okay, or do you want me to go over maybe one more? Yeah, okay, perfect. All right, so let's go on to the second page. Okay, and I know the page numbers look a little funny because there's a 2 there. Ignore that, I'm sorry. You're doing both pages. You're just doing the left side of both pages. Don't worry about page 1, page 2, doesn't matter. But our second page here, this simplifying radical expressions, again, you're only going to be doing the left side of the paper, 1, 3, 5, 7, 9, 11, 13, just the odd numbers. And we'll do a couple of them together. Let's do number 3. So I'm going to zoom in here to number 3. Okay, so I don't have my perfect squares listed on my screen here. But I'm going to tell you this here, 512, that is not a perfect square. So that means we're going to have to split this up, square root of something times square root of something. Okay, and this is one of the harder ones because it's a bigger number. But remember, again, just like what we've been doing before, the first one here, the first square root, this needs to be a perfect square. Perfect square, and then this one's not perfect. Okay, that's okay. Not everyone's perfect, but we're all perfect in our own ways. Doesn't matter. Okay, but the first one, perfect square. So we need to think something times something else is a perfect square. And I'm going to help you guys out with this one. But for number 3, we can do 256 times 2 because 256 is a perfect square, and I will show you guys in just a minute. It's bigger than 12, So that's why it's not something you guys know off the top of your head. That's why I'm just kind of helping you guys out with this one here. But you can always keep on going. If your number is bigger than 144, then just keep on going. You can do 13 squared and then 14 squared, 15 squared, 16 squared. You can keep on going and list out all of your choices. Take as much time as you need to list out all of your perfect squares when you're doing this. And that's going to help you guys out later on in the road. It's going to take a little bit of extra time in the beginning, but it'll help you later on. But we didn't do that, so that's why I'm kind of just giving you this answer here. But it's the 256 times 2, where 256 is a perfect square. We just don't know what it is yet. And then we're looking at this k squared. Okay, in order for a variable to be a perfect square, it needs to be divisible by 2. Can we do that exponent of 2? Can you do 2 divided by 2 and get a nice whole number? If it's an even number, then yes, you can. Okay, so that perfect square k squared, I'm going to put it under the perfect square, k squared. Okay, and then that means there's no other variables left. So we have the perfect square square root of 256k squared times the non-perfect of square root of 2. And then we're just going to do our square root. Let's do our square root of this first one here. Square root of 256, or what times what, same thing, is 256. Well, if you were to continue doing this, 13 squared, 14 squared, 15 squared, 16 squared, you would then find out that eventually 16 squared, or 16 times 16, is 256. Okay? And then let's figure out our square root of k squared. With variables, remember, all you do is take your exponent. I'm going to bring down my variable. You're going to take your exponent, whatever it is. This one is 2, and you're going to divide it by 2. So what is 2 divided by 2? 2 divided by 2 is just 1. So here's my exponent of 1. Perfect. And then I'm just going to drag down this square root of 2. This would be your final answer. But really quickly, let's just erase that 1, the exponent of 1, because it's invisible. We don't need it there. Okay, so that would be your final answer there. It's pretty much the same thing as before, but we're just adding in some variables and exponent. Let's do another one together here. Let's do number 5. Okay, we'll do number 5. We've got square root of 216 k to the 4th power. Okay, so 216 is not a perfect square, so we need to split it up. Perfect square times the not perfect square. Let's look at just the numbers. We've got 216, so we need to get a perfect square times the not perfect. What could we do? What times what? I'm going to help you guys out here. Your not perfect square is 6. Just to help you guys out here, because it is some of our bigger numbers here. What times 6 would be 216? And remember, this one is a perfect square, which we listed on the first page. So what perfect square times 6 is 216? And you can type it in the chat there. If you think you have it, type it in the chat. I see some typing. 6 and 36. Perfect. 36 is the perfect square. 36 times 6 is 216. Perfect. Now let's look at our variable. We've got k to the power of 4. Is k to the power of 4 is 4 divisible by 2? Or think, can you do 4 divided by 2? Yes or no? Yes, you can. It's an even number. So we're going to keep that k to the power of 4 in our perfect square area, okay? That means we went through the entire thing. We did our numbers. We did our variables. Now let's go ahead and simplify. Let's simplify this here. What is the square root of, let's look at just our numbers. What's the square root of 36? 6. Perfect. Okay, and then we've got the square root of k to the power of 4. Here's my variable k. All you do is take your exponent 4, divide that by 2. So what's my new exponent for k? 2. Perfect, because, whoops, because 4 divided by 2 is 2. So that 36k to the power of 4, square root all of that, we get 6k squared. And then I'm just going to drag down this square root of 6. And then that is your final answer there for number 5. Okay? Sorry, my dogs are playing there in the background. Last question here together. Let's do number 9. I'm going to let them outside. Hold on 1 second. Okay. Alrighty, number 9. So 147 is not a perfect square. Again, let's split it up. Perfect square times not perfect square. So perfect, not perfect. So I'm going to help you guys out with this one here. You're not perfect. And you think of what times, I'm telling you 3 equals 147. I'm helping you guys out with this one. Your first number, it's going to be one of your perfect squares. So it's either 1, 4, 9, 16, 25, keep on going. One of those times 3 is 147. And then you can type that in the chat. What times 3 is 147? It's going to be a perfect square. And I see 49. Perfect. That's what I'm looking for. 49 is a perfect square times 3, which is not a perfect square, is 147. Okay, so we've got our numbers. Now let's look at our variables m. M to the power of 3. So here's our m to the power of 3 is the exponent of 3 is 3 divisible by 2. Can we do 3 divided by 2 and get a whole number? Yes or no? No, we can't. So we're going to have to split this one up. I'm going to have some m's here and some m's over here that are not perfect. Okay, so for my perfect square, m to the power of 3, I'm just going to take my exponent of 3, and then I'm going to do minus 1. Okay, 3 minus 1 is 2. And then I'm going to take that last one, 1. So now 2 plus 1 is 3. I just kind of split it up. I put 1 over here in the not perfect, and then the rest of them for the perfect. All you do is subtract 1. So then that m, the variable m, is all good. Now let's look at our variable n. N as in Nancy. Okay, n to the power of 3. We already know the exponent of 3 is not divisible by 2. So that means I'm going to have some in the perfect and some in the not perfect. Okay, what exponent am I going to put in the perfect square for n as in Nancy? What exponent can I put in the perfect square for n? N to the power of what is going to go here? Power of 2, perfect. That means what's going to go with our exponent for n in the not perfect? Exponent of what? One, perfect, because 2 plus 1 is 3. Okay, awesome. And then let's go ahead and simplify this out. Our first one here, what's the square root of 49? Well, we know that's one of our perfect squares. Square root of 49 is 7. Perfect. And then we've got our variables here. Let's do our first variable, m. What is the square root of m to the power of 2? All you do is take your exponent of 2, divided by 2. 2 divided by 2 is 1. And then we got the next variable, n. What's my new exponent for n here? 1. Perfect, because you just take your exponent 2. 2 divided by 2 is 1. Perfect. And then I'm just going to drag down this square root, 3m to the power of 1, n to the power of 1. Okay, this would be your final answer, but let's clean it up a little bit. All of those exponents of 1 are invisible. So I'm just going to erase all of those exponents of 1. Erase, 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 because they're all invisible. We don't see them now. We can go ahead and write them in, and it's the same exact thing. But this right here is the most simplified way to write your final answer there for number 9. Okay, so hopefully that's enough practice for you guys. You're pretty much going to be doing the same thing here for all of this second page. You're going to do your perfect square times your not perfect square. And then that is it. So hopefully that's enough time and practice for you guys to do both pages here. But that's pretty much it. Finish working on both pages, just the left side, all the odd numbers. Show your work, submit a picture. There's no school tomorrow, so that means no meeting tomorrow, no work tomorrow, or if you've got nothing to do, you can work on missing work. And then we'll meet again on Monday. But that is it. If you have no questions for me, you can go ahead and log out. Just make sure you say something in the chat before you leave. But if not, I will be here. But I'm going to go ahead and end my meeting, and then I'll answer some questions there. I'm going to stop recording.